Dissociation constants for acids and bases. These are going to be a lot like the equilibrium constants that we wrote for the other, for the chapter right before this one, where we wrote the products on the top and the reactants on the bottom. The reaction here would be A plus B is making C plus D. Okay, so we can do the same thing with formic acid and the formate ion. The only difference we're going to have here is that we have water in our reaction, and the concentration of water is not going to change. So we leave it out of our equation. Down here we don't have any water. No water. In strong acids, we find that they are very successful in being able to get rid of their proton, so they tend to make more products. If we make more products, our product number here is a large amount of product and a small amount of reactant is left at equilibrium, and so we expect our Ka to be a large number. Oops, an E in there. Okay? And it dissociates completely. If we have a strong base, like sodium hydroxide, we also find that this will make more product, and that our Ka will also be large because we'll have lots of product, lots of product, not much reactant, and that makes this a large number. With a weak acid, we find that it's not very successful. This bicarb is not going to be very successful at getting rid of this hydrogen, and it's going to make more reactants. That translates with our Ka is that we have not much product and a whole lot of reactant. And that makes this number very small. With a weak base, we'll find basically the same thing, that the reactants will be favored and the Kb will be very small.